You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Cloud Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Virtualization is the foundation that enables cloud computing. It allows multiple operating systems to run on a single piece of hardware by abstracting the physical components and dividing them into virtual environments. At the heart of this process is the hypervisor, a specialized software layer that allocates resources, controls guest systems, and manages isolation. Understanding virtualization means understanding how hypervisors enable flexibility, scalability, and efficiency within cloud platforms. Whether the system hosts one virtual machine or hundreds, the hypervisor dictates performance, behavior, and availability. There are two main types of hypervisors: Type 1 and Type 2. These differ in how they interact with hardware, how they are deployed, and what use cases they are suited for. Type 1 hypervisors, also known as bare metal, operate directly on the host hardware. Type 2 hypervisors, often called hosted, rely on an underlying operating system. The Cloud Plus exam requires candidates to compare both types, understand where they are typically used, and evaluate the trade-offs in performance, manageability, and cost. This episode explains how each type works and why knowing the difference matters in real-world cloud scenarios. A hypervisor is the central component in any virtualization stack. It acts as the controller for virtual machines, allowing multiple guest operating systems to run on one physical host. It isolates workloads from each other, manages memory allocation, and mediates access to CPU and storage resources. Without the hypervisor, virtual machines would be unable to share physical hardware. In the context of cloud computing, the hypervisor makes it possible to run multiple tenants securely and efficiently on shared infrastructure, while maintaining separation and control. Type 1 hypervisors, also called bare metal hypervisors, run directly on the physical hardware without the need for a host operating system. This means the hypervisor itself functions as the operating layer and communicates directly with device drivers and system firmware. This direct access enables improved performance and lower latency, making Type 1 hypervisors ideal for production environments. Examples of Type 1 platforms include VMware ESXi, Microsoft Hyper-V in server mode, and kernel-based virtual machine, often referred to as K versus M. These are typically deployed in enterprise data centers or cloud provider infrastructure. The benefits of Type 1 hypervisors begin with performance. Because there is no host operating system in the middle, virtual machines interact with hardware with less overhead. These hypervisors also present a smaller attack surface, reducing vulnerability risk. They support advanced security features, including role-based access control and secure boot. Type 1 hypervisors are designed for stability, scalability, and reliability. As a result, they are commonly used in cloud data centers, virtualization clusters, and mission-critical environments where uptime and consistency are required. Type 2 hypervisors are installed on top of a host operating system. They function as applications that rely on the underlying OS for device management, scheduling, and resource access. This design makes Type 2 hypervisors more accessible for testing, development, or training use cases, especially on laptops or desktops. Examples include VMware Workstation, Oracle VirtualBox, and Parallels for macOS. These platforms offer flexibility for individual users but are not optimized for large-scale production workloads. They allow users to experiment with virtual machines without deploying a full enterprise-grade virtualization stack. Type 2 hypervisors are commonly used in desktop labs or training simulations. Because they operate within a host operating system, they are easy to install and manage with graphical interfaces. These hypervisors are well suited for software testing, developer sandboxes, or environments where portability and ease of setup are more important than raw performance. They are not used for enterprise scale or performance-sensitive workloads. Cloud professionals may use Type 2 hypervisors for lightweight virtual machine testing, but should not rely on them for production deployment scenarios. The core architectural difference between the two hypervisor types lies in how they interact with hardware and the operating system. Type 1 hypervisors run directly on the physical server, enabling them to manage hardware resources natively. This results in reduced overhead and improved efficiency. Type 2 hypervisors, in contrast, depend on the host operating system to handle device drivers and hardware interaction. This added layer introduces latency and complexity. Understanding these architectural distinctions helps cloud professionals choose the correct hypervisor type based on project needs and performance expectations. In terms of performance, Type 1 hypervisors typically deliver near-native speed for virtual machines. Because there is no host operating system in between, there is less interference with CPU scheduling, memory access, and I/O handling. Type 2 hypervisors, on the other hand, must share resources with the host OS, and this can create contention or delays. For production systems or any environment requiring guaranteed performance, Type 1 is preferred. Type 2 is better suited to non-critical tasks where convenience is more important than speed or reliability. Security is also affected by the hypervisor type. Type 1 hypervisors benefit from reduced complexity and fewer software layers, which limits the number of potential vulnerabilities. They are usually hardened with security modules, and patches are centrally managed through platform tools. Type 2 hypervisors inherit all of the vulnerabilities of the host operating system. If the OS is compromised, so is the hypervisor. Both types require patching and isolation, but Type 1 platforms are generally considered more secure for enterprise or multi-tenant environments. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Licensing models and cost structures vary significantly between hypervisor types. Type 1 hypervisors are often commercial-grade solutions that require licenses for advanced features or enterprise support. These licenses may include tools for centralized management, high availability, or live migration. In contrast, many Type 2 hypervisors are open source, free to use, or bundled with development tools. This makes Type 2 more accessible for individuals or teams with limited budgets. The total cost of ownership must be considered when choosing a hypervisor for a project, especially when scaling across dozens or hundreds of hosts. Hardware compatibility plays a crucial role in hypervisor selection. Type 1 hypervisors require hardware-level virtualization support, which must be enabled in system firmware or BIOS. Without these features, the hypervisor cannot run efficiently or at all. Type 2 hypervisors, being hosted on traditional operating systems, are more forgiving. They can operate on most desktops or laptops, even if hardware acceleration is limited. For production cloud environments, Type 1 hypervisors are favored because they align with hardware expectations for consistent performance and scalability across large server fleets. One major advantage of Type 1 hypervisors is support for high availability and live migration. These features allow virtual machines to be moved between hosts without downtime and enable failover scenarios when a server fails. These capabilities are essential for cloud infrastructure, where uptime and service continuity are critical. Type 2 hypervisors generally do not offer these features, as they are designed for local use on single-user systems. Cloud environments that require redundancy, workload balancing, and disaster recovery features must rely on Type 1 platforms to meet those requirements. Most public cloud providers use Type 1 hypervisors as the base layer for their virtualization platforms. Providers like AWS, Azure, and Google Cloud rely on these hypervisors to host virtual machines across thousands of servers. Type 2 hypervisors are more common in developer workstations, QA test environments, or instructor-led training setups. Understanding which hypervisor is used in a given scenario helps with interpreting cloud architecture and answering certification exam questions. Candidates should recognize that cloud services are built on bare metal virtualization platforms designed for high performance and isolation. The Cloud Plus exam includes direct references to virtualization types. Candidates may be asked to evaluate a scenario and recommend the appropriate hypervisor based on use case. Examples may include questions about choosing between a Type 1 hypervisor for a resilient enterprise rollout or a Type 2 hypervisor for a local development lab. Understanding the characteristics of each type, such as their performance, security posture, and management interfaces, helps candidates match the correct virtualization model to the needs of the environment being described. Hypervisors and containers are both virtualization technologies, but they function differently. Hypervisors provide full hardware virtualization, enabling each virtual machine to run its own operating system with isolated kernels. Containers share the host kernel but isolate processes and libraries, offering faster startup and lower overhead. In cloud environments, both technologies may be used together. Hypervisors provide the foundation for infrastructure-level virtualization, while containers optimize application deployment at scale. Candidates must understand how these models coexist and why each has its place in modern architectures. Troubleshooting virtualization issues requires the right tools. Type 1 hypervisors often include built-in tools for logging events, viewing system resource use, and managing guest behavior. These may be accessed through web portals or centralized management consoles like vCenter or SCVMM. Type 2 hypervisors rely more on host OS logs and GUI tools. Understanding where to find logs, how to interpret error messages, and how to monitor system state is critical. Different hypervisor types require different approaches to identifying the source of problems and resolving them efficiently. Private cloud platforms often use Type 1 hypervisors as their base infrastructure. These environments are built to mimic the scalability and reliability of public clouds, but are hosted within an organization's own data center. Type 1 hypervisors provide the necessary control, security, and performance needed for multi-tenant internal use. They also integrate with virtual switches, storage arrays, and automation frameworks. Candidates should understand how private clouds leverage Type 1 hypervisors to replicate cloud functionality without relying on external providers. The selection of a hypervisor depends on several criteria. Type 1 is the preferred choice for enterprise environments that demand performance, uptime, and scalability. It supports complex features and is tightly integrated into cloud platforms. Type 2 is ideal for lower-risk environments, such as software development, experimentation, or training labs. It provides convenience and flexibility without the need for specialized hardware or licensing. Matching the hypervisor to the needs of the environment ensures that the virtualization layer supports the workload, rather than becoming a bottleneck. Hypervisors are essential to the design and operation of cloud environments. Type 1 hypervisors are used to deliver production-grade performance and reliability, while Type 2 hypervisors support training and testing scenarios. Understanding their differences helps cloud professionals make better decisions when architecting systems or troubleshooting behavior. The Cloud Plus exam will expect candidates to recognize when and why each hypervisor type should be used. Knowing their strengths and limitations is not just an academic exercise. It is foundational to cloud deployment success. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.